Hello guys and welcome back to my channel. Today I'm gonna talk about a tool that is essential in a lab or in a working space where you need to test out electronics, and that's a power supply. Having a power supply in your lab offers you a lot of options and informations about the devices you are testing. And in FPV it makes a world of difference when you build out quads. You have a power supply at your disposal to power up your setup and see how much current it draws, and also offer you some sort of protection in case that you did something wrong building that quad in particular. So I cannot tell you how important is to have a power supply in your lab. Now I am gonna talk about this power supply, which is a Riden RD6012, and that means that it can go up to 60 volts output and 12 amps. There is also a 6 amp version of this power supply. For most FPV related stuff, 6 amps is more than enough, but I personally repair a lot of stuff that's not FPV related, and most of the times I need 48 volts at 10 amps. So this is why I'm so interested in this particular power supply, which is a switching power supply, hence the smallness of the power supply, because if you would take a linear power supply which can deliver 12 amps, most definitely that one would be significantly bigger than this and obviously heavier, because linear power supplies usually tend to have a transformer and not a switching power supply to take the AC out of your wall and transfer it to your power supply. You can use this power supply as it is. You can just feed here 60 volts or less, depending on what's your output voltage requirements. If you plug here 30 volts, your max output would be 30 volts. You can design a case for it or just use it like this on the bench. I would recommend a case and a very good power supply for it. And luckily Banggood is selling this power supply together with two other options, which is a case and a power supply. And today I'm gonna build that case with this power supply and the switching power supply for the AC. What I like about this power supply is the price, which sits around $60–70, something around there. Depends a lot if you choose with Wi-Fi or not. But the thing is that the quality inside is quite decent for this amount of price. And a few years back, this would be not possible to have such a great design in this small form factor. So, in the package of the power supply, we can find a temperature sensor, because this power supply can actually charge batteries. So you have a temperature sensor here, which you could place on your battery for safety. You have here some wire terminations for screwing the cables onto a power supply or something like that. And also we see a fuse. And this is all we have with the power supply itself. And this is the case, which is a metal case. And the power supply just slides in here and clips in place. On the back we have place for one fan in case you are using a power supply that doesn't have a fan. You have the AC connection here and most definitely a switch here, but we will have a look. On the back they sent for this case, which should have everything inside. Let me get closer a bit. So we have here the switch, as I've said. We have the AC connector here, which is a basic type. We have a lot of cables already crimped and ready to go. Also the cables for connecting the power supply, and in this bag we have a lot of screws and things for the case, and rubber fit for the case also. I will put them aside. And here we have the power supply, the AC power supply, which came pretty deformed by the shipping. I will show you just in a bit. So as you can see here, they messed it up quite heavily on the shipping. We can just straighten it up just for it to look a little bit better. So I managed to make this kind of straight. This is the power supply. Most definitely is a clone of Meanwell. I would recommend though to take a Meanwell power supply, even though it will be a lot more expensive. But let's hope this power supply will be okay for our purpose. I will put the power supply aside and take the case. Just taking out the screws. Let's take the cover off. So I will just place the switch inside. Everything looks to be okay. I will take the AC plug, put it in, and I have here some nuts. Just putting some screws and nuts on there. What I like about this approach is that the whole power supply will look much more professional and protected and easy to use. Just switch on the power and off you go to work. So we have this here all set up. Let's take now the power supply and see where we can install it. Maybe here. This is mounted the other way around like this. The fan is sitting right to the fan exhaust there. Let's take some screws and we just need to line up the things in the power supply, because the power supply has some nuts already in place. So we are actually screwing on into the power supply itself. One hole is fixed. We have another one here and two on the bottom side. And if I'm not mistaken, we have one in the middle. Tightening the screws to be sure they are tight and nice. So these are the screws that are holding the AC power supply. 1, 2, 3, 4 and 5. You still have here 4 more holes to use if you want extra strength, but 5 screws is way more than enough. And now I'm going to take the AC cables. We have this type, which are going to the power supply itself, and we have this type, which are also protected, that go on our thing here. So first I'm gonna install the grounding. We have one more here, and one goes to the switch here, and our little cable goes from the plug to the switch, and we are done. Now we need to go and screw on the cables on the power supply terminals. We have here a plastic cover that goes up. So we have here all 3 connections for AC. We have the ground, which is here. And we also have the neutral, which is always or almost always blue. The live wire, which is the brown one, passes through the switch, and that's how we close the power going to the power supply. Good. We will tidy this later. We should test our power supply. My switch is set on off. I just plugged to 20 because I live in Europe. And let's power it up. The power supply started. It's a cheap power supply. It doesn't have a fan controlled by the heating of the power supply, or at least the current draw, so it's always running. Let's power it off. So right now the power supply is actually working, and we have to go onto the Riden power supply, which is this one, and connect the 4 supplied cables here. So if we look inside, we can see in positive and in negative. On the in positive, we will install the red cables, which are these ones, and we will install one. And be sure we are screwing the screws pretty good, because we want a solid connection here, because all of that current needs a solid connection. We can do it like this too. Okay, so and one more cable, which is a negative. And now we have a connection for our power supply, which goes like this. And if I am here now, I will just place the Wi-Fi board inside. I don't know if I will ever use it or not, but it will be way easier to install it now. And the final step, or almost the final step. Okay guys, so the power supply went into the case without any issues. Now we have to connect the cables that are taking the power from our AC power supply and feeds in the Riden power supply. We have 2 grounds which are going to the common posts. And now we have the positive connections going to the positive posts on the AC power supply. And we have one more thing to add, because in the AC power supply there is this package here that tells us that there will be high frequency noise when the switching power supply is powered on, which can be improved by adding a load resistor as shown in the figure. And if we look closely here, we have the resistor connected to COM and plus connection, and that's effectively a load for the power supply. So we are going to connect that resistor here, and that's our little resistor there. These cables are pretty okay like this. If you can see here, I added 2 zip ties just to hold these AC cables a little bit more tidy. Everything looks to be in order. Let's feed in AC and power on the power supply. And everything looks to be in order. So this DC power supply from Riden can accept 70 volts max, so I've adjusted the AC power supply to generate 65, and that's not to work with this DC power supply at its max input voltage, so this is why I lowered it to 65. So now next thing is going to be placing the case back in, and we have 4 screws on the side. Which I will be installing now. One side is finished. We have one more side here. All done with the case screws. And now we have one last thing to do, and that's installing this rubber fit, which will go here. Okay, so the power supply is finally finished. I will take out the screen protector and let's power it on. So as you can see, we have a bunch of settings at our disposal. We have the 5 volts output, 1 amp, and we also have protections like over voltage protection and over current protection. And you can use that however you would want. And what this power supply gives you is comfort in knowing that even if you did something wrong on your build, it will protect your electronics, and in the same time it will give you a means of diagnosing broken stuff, like knowing exactly how much amperage one device is taking, and that way you can know some information about if the device is working correctly or not. Power this on, you just press on, and as you can see we have at the output 5 volts. Obviously 0 amps because nothing is drawn. So for example, I will hook up a TBS Unify Pro 32 and I will connect the positive here and the negative here. Okay, so now if I power it on, it should not work because the VTX is working from 7 volts up to 26. So if I power it on, nothing happens. So let's set the output voltage to 7 volts. So we go VSet. We can go like this and go 6, 7. Enter and on. As you can see, our over voltage protection is stripped right now because it's set to 5 volt there. So let's press Shift, over voltage protection, and let's go to 10 volts. Enter, on. As you can see, the VTX started working on 7 volts and we have 200 milliamperes drawn right now, and that's 1.40 watts. And this VTX is not set up for max wattage, so that would be higher. So let's try and go to 10 volts. VSet 10 volts. And our over voltage protection tripped again. Okay, so this doesn't need to be set on your output voltage, but I just put it there for you to see. So the same power, but the amperage went down because the voltage went up. So this is Ohm's law, and this is how you can diagnose that something is broken. Because if you know a good product draws a set amount of current, then you can gauge if something is wrong or not with your device. Because if this VTX should have drawn like 600 milliamperes, that's 0.6 amps, and it only draws like 140 milliamperes, then something is wrong with it. Not with this one, because this one is in pit mode, I believe, or something like that. So the output power is not fully set up right now. This is just a quick overview of what you can do with this power supply. Obviously you can power on your quads and see how much current they are drawing with everything in standby, I mean no running motors, so that also can give you an idea of if something is wrong or not with your quad. But either way, a power supply on your bench is pretty important to have. This Riden power supply is one of the best on the market price-wise, because normally lab power supply are a very expensive thing and they can go up in thousands of dollars and even higher if specifications are very high. I hope this video helped you. Obviously you have all the links for this device in the description. And if you want me to make more of these videos, please leave your thoughts in the comment section, and please don't forget to subscribe for more videos in the future. Thank you very much, and till the next time, bye.